In this problem, we need to find the derivative of the inverse tangent of 1 plus 2x over 1 minus 2x with respect to square root of 1 plus 4x squared. So what we'll do here, we will make an assumption. We'll suppose that u, which is a function of x, let this be equals to inverse tangent of 1 plus 2x divided by 1 minus 2x. And we'll make another assumption. We'll consider another function v, which is a function of x, to be equals to square root of 1 plus 4x squared. Now what we'll do, we'll take the derivative of u with respect to x, which is the same as taking the derivative of the inverse tangent function, which is tangent inverse of 1 plus 2x over 1 minus 2x. So here we are going to use the derivative with respect to x of the inverse tangent function, so that's given by 1 over 1 plus x squared. Then in a case x is given by 1 plus 2x divided by 1 minus 2x, so here we'll have to use the chain rule. First let's find the derivative of the inverse tangent function. So here we will get 1 divided by 1 plus, so here we have 1 plus 2x divided by 1 minus 2x whole squared. So this will be multiplied to derivative with respect to x of 1 plus 2x divided by 1 minus 2x. So let's find it out. So here we will have 1 minus 2x whole squared divided by 1 minus 2x whole squared plus 1 plus 2x whole squared. Now here we will have to apply the quotient rule. For this we will start with the denominator. Here we have 1 minus 2x, we'll square it. And then in the numerator, we'll again start with the denominator value, which is 1 minus 2x. Multiply it to the derivative of the numerator, which is 1 plus 2x. Minus, we'll keep the numerator aside, 1 plus 2x, and multiply it to the derivative of the denominator, which is 1 minus 2x. Right. So here, 1 minus 2x whole square, so this and the denominator expression goes away, and that leaves us with, in the numerator, we have 1 minus 2x. So here, derivative of 1 plus 2x, 1 being a constant, will have 0. Derivative of 2x will be simply 2. Minus 1 plus 2x multiplied to derivative of 1 is 0. Minus derivative of 2x will be negative 2. Whole divided by 1 minus 2x whole squared plus 1 plus 2x whole squared. So let's further simplify it. So here in the numerator, we have 2 minus 4x plus 2 plus 4x divided by, it will expand 1 minus 2 whole x, 2x whole squared. So that's 1 minus 4x plus 4x squared. Plus 1 plus 2x whole squared will be 1 plus 4x plus 4x squared. So here negative 4x and positive 4x goes away. And also in the numerator, negative 4x, positive 4x goes away. So we have 4 divided by 1 plus 1 will be 2 plus 8x squared. So we can divide both numerator and denominator with 2. So we have 2 divided by 1 plus 4x squared. So this is the derivative of the function u with respect to x. So let's label this as number 1. Next, what we'll do, we will take the derivative of v with respect to x. Square root of 1 plus 4x squared. So taking its derivative with respect to x will be equals to derivative with respect to x of 1 plus 4x squared, the whole raised to the power of 1/2. So this will be equals to half multiplied to 1 plus 4x squared raised to the power of half minus 1 multiplied to derivative with respect to x of 1 plus 4x squared. So here we have applied the chain rule. So that gives us half multiplied to 1 plus 4x squared whole raised to the power of negative half times the derivative with respect to x of 1. 1 is a constant, that will be 0, and derivative of 4x squared will be 8x. So here 2 times 4 is 8, so we have 4x. And that gives us derivative with respect to x, derivative of v with respect to x will be 4x divided by square root of 1 plus 4x squared. Right. So let's label this as number 2. So here we have 1, which is du over dx, and we have obtained dv over dx. So what we'll do, we will divide 1 with 2. So we will have du with respect to dx divided by dv with respect to dx. So in du over dx, we obtain 2 divided by 1 plus 4x squared. So that's 2 divided by 1 plus 4x squared. So this is divided by equation number 2. So that's simply square root of 1 plus 4x squared divided by 4x. So this gives us, so we have 2 times 2x is 4x. So this gives us 1 over 2x multiplied to square root of 1 plus 4x squared. So here du over dx divided by dv over dx, so that's simply du over dx. And we considered u to be equals to inverse tangent of 1 plus 2x divided by 1 minus 2x. So this divided by d of square root of 1 plus 4x squared. So this value is equals to 1 over 2x times square root of 1 plus 4x squared. However, there is also an alternative way to solving this particular problem. So here u can be also expressed as tangent inverse of 1 added to tangent inverse of 2x. Here what we have done, we have used the identity that tangent inverse of x plus tangent inverse of y, so that's equals to tangent inverse of x plus y divided by x minus y. So that means when we take the derivative of u with respect to x, so that will be simply equals to derivative with respect to x of tangent inverse of 2x. Tangent inverse of 1 being a constant, so tangent inverse of 1 is a constant, and its derivative with respect to x will be 0, which will be simply equals to 1 plus 2x whole square times derivative with respect to x of 2x. And that gives us 2 divided by 1 plus 4x squared. So this is exactly what we obtained, and taking the derivative of v of x in the similar fashion, we will get derivative of v with respect to x is equals to 4x divided by square root of 1 plus 4x squared, and we'll follow the usual method of dividing equation 1 with equation 2, and that is going to give us the required derivative.